So let's graph y equals sine of x on this interval. So if I'm going from negative pi over 6, I know that that y value right there would be negative 1/2. And then sine of x goes up and down. Whoops, it goes through the origin, right? And then comes over to here. So it doesn't include that one. It does include that one. Okay, and this y value is negative 1/2. And then this y value, let me just erase that little thing. Okay, this y value goes down to negative 1, right? Okay, so I want to find out where the absolute max and min. So absolute max would be the very, very, very highest y value, and I want to know the x that it occurs at, and so that would be here. F of pi over 2, that's 1. That's the one, only one. Okay, is there an absolute min? Is there a very, very smallest y value? Right there. So that would be f of, and you know that's 3 pi over 2. That's negative 1. So now, to find the local extrema, local means where there's a peak or a valley. This endpoint here is not a candidate. So nope, and nope. So this absolute max is also a local max because there's a peak there. And then this absolute minimum is also a local minimum because there's a valley there. All right, let's look at this one. Absolute value of negative absolute value of x. Sorry, I said that wrong. Looks like that. Okay, so let's look at where the interval is. So the interval is from here, negative 2, include that. And they do a little erasing here. And then only goes up to x equals 1. So that would be the open circle there. Okay, these are supposed to be straight lines, right? All right, so let's look at absolute max. So absolute max is the very, very highest y value. So that occurs at 0, right? F of 0 is 0, right there. And absolute min, that would occur right there, which is f of negative 2, which you know is negative 2. Okay, so now let's look at local max. Local max is where there's a peak. I think it's the same. F of 0 is 0, right? There's an area around where it's a maximum. And is there a local minimum? Is there an area around something? No. So there's no local minimum. There's no valley is what you could think of. All right, maximum error in finding the volume. That's a very long way of saying find dV. And you know the volume is x cubed if we're talking about a cube. So dV is 3x squared dx. And then what do they tell us? The side length is measured as 2, and the error in measurement is 0.004. So I just get to plug that information in. I put the 2 in for the x and the 0.004 for the dx, so 0.048. So that's how much the volume is off because of the mismeasurement of the radius, or the side length, side length. Okay, so percentage error. So first you have to find the relative error in volume. So that means you got to find dV over V. So what are we talking about here? We're talking about a sphere. So you know the volume of a sphere is 4/3 pi r cubed. And so do this first. So dV over V, 4/3 pi. And dV means you take the derivative of the r cubed, so 3r squared dr, and then just replace what V is down here. I want to make sure you're doing it the easiest way possible. Oh, look at that. Look at how much cancels. Those and some r's. So you end up getting dV over V is 3 dr over r. So much easier than plugging the numbers into everything, right? So now I'm going to plug in that the error in measurement is 0.03. So that means dr is 0.03. And the radius was measured as 4. So dv over v is 0.03 times the 3, right? So I lost the 3 there. 3 times 0.03 divided by 4. So that decimal gives me 0.0225. And they want me to find the percentage error. So the percentage error means I just write that as a decimal. So that gives me, from here, I get 2.25%. So that's the percentage error. All right, this one here, you're looking at a function to a function. So you know, I'm not going to tell you this on a test or a quiz. You know you need to do log diff. So that means you have to start with taking ln of both sides. So remember, almost always the mistakes happen on this first step, so go slow. Then bring the ln of x down in the front. And you know you're always going to have product rule on this right-hand side. So I take the derivative, and I get 1 over y prime, and over here, first d second, 1 over secant, and then times derivative of secant, which is secant tangent, plus ln of secant times the derivative of ln of x, which is 1 over x. So I can do a little canceling, right? And I'm going to solve for y prime by multiplying through by y, and I want to replace what y is equal to, so that's secant of x to the ln of x, and then all times this here, right? So I'd have ln of x times tangent plus ln of secant of x all over x. And that would be the answer for 5.